What is the angle formed on an analog clock by the minute and hour hands at 4:16 p.m.? All right. Well, for this problem, let's start by just sort of drawing on this clock here. I'm going to actually pick up another color. Well, okay, let's do this. And let's draw in the hands. Now, at 4 o'clock, the hour hand is pointing to 4, and the minute hand is pointing straight up. And at 4:16, the minute hand is pointing right over here, just below 4:15, so somewhere in there. And the hour hand also moves continuously as the hour goes on. So it's about a quarter of the way. The minute, we're about a quarter of the way through the hour, a little more. So we're going to be about a quarter of the way between the 4 and the 5. So we could sketch it in and it would look somewhere like that. Maybe that's a little bit off, but it's probably, it's about, if you were to divide this up, oops, it's probably pointing somewhere into around here. Okay, so that's just an estimate, and that, at least that gives us a little bit of an idea of what kind of answer we are expecting. Okay, so that'll help us, because it looks like, there's 360 degrees in the circle, and there's 12 hours around this circular clock. So that means there's that each number here, so that the angle from the 12 to the 1 is 30 degrees. Okay? And then we have 12 of those 30-degree marks around the circle. So if you look at this, we're looking somewhere in the 30-degree range here. so that gives us an idea of what angle we're looking for. So, well, let's start just by looking at what happens with a clock. The minute hand moves continuously throughout the hour, right? So, and the minute hand goes around once in an hour. Okay, so it goes 360 degrees in 60 minutes. And if you reduce that fraction down, that's 6 degrees per minute. Okay, so you see I just divided 360 by 60 to get the number of degrees that the hand moves per minute. And we can do the same thing for the hour hand. Now the hour hand doesn't move as fast. Okay, so for the hour hand, it just moves 30 degrees in an hour, right? It just goes from, or in this case, at 4 o'clock, it's pointing straight at the 4, and at 5 o'clock, it's pointing straight at the 5. So if the angle between 4 and 5 is 30 degrees, then it's moving 30 degrees in 60 minutes. Okay? And we can reduce that down to 1/2 of a degree per minute. Okay, so now we know the rates that the two hands move. And from that, we can find out how far they move within the hour. Okay, so at the top of the hour, let's look first of all at the minute hand. At the top of the hour, the hand is pointing straight at the 12. And after 16 minutes, so we go 16 minutes because we're at 4:16, it moves 6 degrees times 16 minutes. Okay, so that's a total of 96 degrees. So that tells us that the angle here from 12 over to where the minute hand ends 16 minutes after the hour is 96 degrees. Okay, so, and that makes sense, just beyond 15, right? And 15 would be 90 degrees. So 15 minutes after the hour, it's 90 degrees, and at 16, it's 96. So you could reason it out that way as well. All right, so again, 16 minutes after the hour, let's look at where the hour hand ends up. It only moves 30 degrees in an hour, so in 16 minutes, okay, it's moving a half a degree per minute, so let's multiply a half a degree per minute times 16 minutes, and that's just going to give us 8 degrees. Okay, no, but that's 8 degrees from the time it was pointing at 4, directly at 4, straight at 4 o'clock, to the position that it's at 4:16. Okay, so it's already starting at the 4, which if I measure that from the 12, that's 30, 60, 90, 120. Okay, so 8 degrees is measured from the 4, but since I measured this from the 12, I'm also going to measure this one for the 12. So that is equal to 128 degrees from the 12. Okay, so I'm measuring the angle from a common reference point. Okay, and we're going to take the common reference point to be the 12. So the angle made between the 12 and the position of the minute hand is 96 degrees, and the angle when you measure it from the 12 to the position of the hour hand at 4:16 is 128 degrees. So now if we know that this is 96, and this, again, measured all the way from here, is 128, but I want to know this angle. So if I take 128 and subtract 96, I'll get that angle. So that is just 32 degrees, which matches our estimation. We were estimating somewhere around 30 degrees, and 32 degrees is pretty close, so we can be fairly confident that that is the right answer. So there you go.